Hi everyone. Assalamualaikum and selamat pagi ya. So today we continue our lesson revision on chapter 3. Okay, electricity. Alright. So look at question number 1. Okay, number 1, which diagram shows the correct electric field pattern? If you look at diagram A, B, C, D. Okay, this one shows electric field. So this one you study in topic 3.1. Electric field. Okay, what you should know about electric field definition. Okay, electric field actually refers to region, satu kawasan. Okay, region where a charged particle experiences electric force. Okay, so you already discussed this one when you draw for, let's say, charge unit, positive. Direction of electric field, we represent it with a line with arrow. Direction of electric field always positive to negative. Okay, means okay, direction that you should mark here is like this, outward. Okay, if negative, inward, ke dalam, because it positive to negative. Okay. Okay, let's look at the question just now. Remember, the properties of line that you draw must be the line with arrow. Okay, and the line cannot cross, cannot cross. Okay, look at A. Which diagram shows correct electric field pattern? This one positive, direction correct already out. This one also out. Positive, positive, same or like charge. Charge yang sama, like charge. That's why the line cannot join together. Okay, ada repel force di tengah. Okay, if you look from here, it's correct. B correct. Okay, B, what is wrong with B? Okay, kalau B, this one is correct, positive out, but this one is wrong. directions should be in, not out. Okay, look at C. This one is negative, negative, should be repel. Okay, so ini juga salah. And then this one, the last one, direction. Okay, either attraction force, but direction is opposite should be. Because direction of electric field always positive to negative. So the answer will be A. Okay, if you have questions, you will write in chat. Okay, number 2. Which of the following statement is correct about electric field line? Okay, look at part 1. Electric field lines around positive charge particle always point inward. Positive, inwards. Negative, outward. So this is wrong. Okay, part 2. Electric field around positive charge always point outwards. Negative, inward. Yeah, this one is correct. Electric field lines do not intersect, meaning cannot cross. So this one is correct. We have 2 and 3 correct. Okay, look at 4. Electric field lines start with positive charge and end with negative charge. Okay, what is the answer for this one? Electric field lines start with positive, end with negative. Yes, electric field always directed from positive to negative. So the answer, this one is correct. So we have answer is D, donkey. Okay, number 3. Figure 1 shows candle placed between 2 plates, F and G, and connected to VLT power supply. Very high voltage, VLT ataupun EHT, extra high tension voltage. Okay, volta lampau tinggi, bahasa Melayu. Okay, put between 2 plates. One you connect to positive, one you connect to negative. Okay, so you can see what happens to the candle flame. We know that the flame consists of ions, positive and negative. Okay. Okay, so when this happens, the positive one will be attracted more to negative. It's something like that. It will produce a non-symmetrical means not symmetry. Large portion will be attracted to negative and small portion will be attracted to positive. This is the properties of a charge. Like charges attract. So the positive charge attracted to negative charge attract to positive. Why large portion? Because positive ions is heavier, lebih berat, mass lebih besar. Macam orang badan gemuk atau besar, dia akan duduk space yang lebih besar. Okay, macam itulah. So large portion of flame attracted to negative. Okay, look at which one is correct. When power supply turn on, the candle flame spread between the 2 metal plates. Explain what happened based on activity, studying the effect of electric field on the flame of candle. Negative ion will be attracted to negative plate. Negative cannot attract, so wrong. Negative ion will be attracted to positive, yes. Positive ion has larger mass and size so that the spread that attract to negative plate is large, yes, correct. 4. Negative ion has larger mass and size and spread to, no, negative ions small mass. We have 2 and 3. So answer B, number 3 should be B, boy. Okay, now let's look at number 4. The charge flow in an electric circuit in 3 minutes is 9 coulomb. What is the current in the circuit? Okay, remember after you have done discuss about charge, you are introduced to charge flow. Okay, charge flow in an electric circuit. Okay, so this one introduced the concept of current. Rate current equals to by T. So this question need you to find charge. Nak cari charge. Make it charge as a title. So you have Q equals IT. Okay. So soalan ialah charge flow. What is current? Ya. Soalan nak current. So kita just guna formula current. So I equals Q divided by T. Have 9 coulomb divided by time in 3 minutes. 3 minutes. You're going to convert to second. Okay. Simplify is 1 over 20. So we get the answer will be number 4. Jawapan. I get 0.05. Okay, answer should be okay. Remember, unit must be careful. Time must be in second. So that you get the unit for current is 0.05. Yeah. Okay, number 5. Before I continue number 5, I also want to explain a little bit more about the okay, for the electric field, about electric field strength. Okay, symbol also E, don't get confused with electrical energy. For a charged particle, the strength of electric field around the charge, apa formula kita nak gunakan? Strength equals to electrical force divided by quantity of charge Q. Okay, so you will get the unit will be in Newton Coulomb -1. Okay, force electric force act. If you put one unit here, okay, this one will be attracted to positive. So what is the force that attract the unit of charge? Then divide by charge, quantity of charge. Okay, this one is for around a charge unit. We have another one. If we have two plates, positive and negative, okay, separation between the two plates is D. There are electric field between, okay, the two plates. Okay, plates, two plates. Okay, so electric field strength equals to F divided by, sorry, not F. Ini kita tak guna F, kita guna V, voltage. And then there's a voltage between the two plates V, so we have E equals to V divided by D. So formula is different between these two. Okay, so unit is voltmeter -1. Okay, so you just check the case lah. If the region is around a charge unit or charge particle, use E equals to F divided by Q, unit Newton per Coulomb. And then if between two plates the voltage V and the distance is D, so you will get E equals to voltage divided by separation distance. Okay, so from here you can see if you put closer the two plate, D smaller, means electric field strength is higher. Or you increase the voltage, electric field strength is higher. Same thing here. If the charge experiences larger force, so electric field strength is higher. If you increase the charge unit here, okay, instead of 1 unit, you're going to 2 unit, 3 units. So E equals to F divided by Q also increases. Okay, so you need electric field strength. Okay, let's look at the next question. Okay, this is about connection of circuit. Connection in the resistors in the circuit. So we have R1, R2, and R3. Okay, so this one we call it series connection. Macam mana you tahu series? You must know this one is positive, negative. So charge flow through R1, R2, and R3 are same. Dia sama current dia. Okay, so this one we call it series. Okay, okay, which statement is correct? This one already mentioned, different resistors. Okay, perintang berbeza. So means different resistance. Okay, resistance dia tak sama. Okay, for series connection, we just apply V equals to IR. Okay, so same I flow means I will become constant. Sebab dia sama untuk semua resistor tu. So we get V directly proportional to R. V adalah sama across here, but they are arranged in series. They will become potential divider. So R1, R2, R3 will share the voltage. Okay, if their resistance is different, means voltage across also different. So the voltage cannot be same. Voltage tak sama. Ini salah. Okay, B, power dissipated by each resistor same, also wrong. Power dissipated P equals to I square R. They have same current but resistance are different, so power dissipated also different. So B is wrong. C, okay, effective resistance is smaller than individual resistance, also wrong. Because if series of the effective resistance, you must add R1 plus R2 plus R3. So effective resistance is greater when you connect in series. Sambung series, dia punya effective resistance bertambah. Okay, but the current passing through each resistor is same. You already showed just now. Total current equals to I1 equals to I2 equals to I3, because they are all in series connection. So answer will be D donkey. Okay, number 3. Diagram 3 shows a single core wire length 60 centimeter. The wire has resistance of 1.7 times 10 to the power negative 8 ohm meter and diameter 0.9 millimeter. Soalan, what is resistance of the wire? So for this one, we use this formula. R equals to resistivity times L divided by cross-sectional area. Okay, we have the length 60 centimeter. Resistivity also given, diameter also given. Question want you to find resistance. Okay, we just substitute all the values, but make sure the unit is correct. R. Okay, resistivity given in ohm meter means the unit for length and unit for diameter must change to meter. Okay, so how to find A? A, the cross section is pi r squared, or pi times diameter divided by 2 squared. Okay, so kita try calculate resistivity 1.7 10 power negative 8, length 60 centimeter, I convert to meter, 0.6 divided by pi, diameter 0.9 times 10 power negative 3 divided by 2. I convert to meter squared. Okay, so we solve for this one. We'll get R equals to get 1.6 10 power negative 2. So I get the answer is C for this one. Okay, number 7. Which graph shows correct relationship between R and cross-sectional area? R equals to rho L divided by A. So from here, resistance directly proportional to resistivity, and the resistivity actually depends on material. The higher the resistivity, the higher the resistance. R directly proportional to length. The longer the length, the higher the resistance. R inversely proportional to cross-sectional area. So which graph shows inversely proportional? So you can see clearly from here, B. Number 8. Diagram shows 4 resistors connected with 6-volt battery. So this one is 6 volt. What is the reading of ammeter in the circuit when switch is apabila switch ditutup? When switch is closed lah. Okay, you must understand, ditutup bukan off, ditutup ialah on. Kalau open, switch buka means off. Okay, sama juga switch buka atau switch open. Off. Okay, so tutup means close. Close maksudnya on. Okay, kena faham tu ya. So what is the reading of ammeter when the switch is closed? So close like this means the circuit completed. So current will flow through all parts of the resistor in the circuit. So the question wants you to find reading of ammeter, means you want to find current. Okay, current here. So this is the first resistor, R1, R2, R3, R4. Okay, so this is combination circuit. Combination circuit, normally we want to find the total current first, total current, and also the voltage. Because to calculate current I pass through the 2 ohm, ini I2, so it means I just I1, I1. Because I2, I just put I2 lah. Okay, I2, so here will be I3. So I want to find I2. I'm using this formula. V2 equals to I2 R2. Means I need to find I2 in this case. So I must have V2 R2 already given. So I need to find V2. So how to find the V? Okay, how to find the V? Parallel, it will experience same voltage. Okay, means I need to calculate voltage across this point dulu. Okay, R1 and the parallel part and the R4, we call it potential divider. They are sharing the voltage. So, means I need to find the total effective resistance dulu. Okay, for this part parallel, using the formula of parallel, 1 over parallel part is 1 over R2 plus 1 over R3. 1 over 2 plus 1 over 2 will be 1 ohm. Means R parallel ialah ni 1 ohm. Kita panggil is 1 ohm. Okay, so means I can simplify this circuit. R1, let's say this one is R parallel, then I have another one R4. So they are parallel to each other. Okay, it's like this. So I need to find what is voltage across the parallel part. Okay, so I need to find total current dulu. Using the formula V equals to IR also, if voltage is total current, I is total voltage, VT, I is total current, R must be effective resistance. Okay, so what is effective resistance for the whole circuit? Okay, is 2 plus 1 plus 2, ialah 5 ohm. Okay, so 6 equals to I total 5. (1.2 ampere). Okay, so we have total current 1.2 ampere. So for parallel pipe, if this one is 1.2 ampere, here also 1.2 ampere, here also 1.2 ampere. So I want to find voltage across the parallel pipe. Okay, voltage across parallel pipe is I total multiply effective resistance for parallel. So 1.2 times 1 is 1.2 lah. Sama lah. Okay, sebab dia series kan, dia 1.2. Voltage, volt, sorry, 1.2 volt. So voltage across I2 ialah 1.2 volt. So ganti balik dalam ni. I want to find I2. I2 ialah V2 over R2. V2 equals to voltage across parallel pipe, 1.2 volt. So means 1.2 volt divided by 2 ohm. Okay, so I will get the answer is 0.6 ampere. Okay, kalau you tengok pun you boleh tahu lah sebab ini adalah same resistance. So the current will be divided equally. So 1.2 divided by 2, 0.6. Also can. Okay. Answer A. Number 9, which circuit can be used to determine electromotive force of a dry cell? Okay, we check the connection. Okay, the dry cell, the voltage here connect in series, wrong. Voltage must be parallel. Parallel, you connect it across the battery or you connect it across external resistors, okay. So this one you can see the voltage also connected in series, cannot. Okay, this one also cannot. Okay, and then D, okay, voltage across the battery. Okay, the voltage will, okay, when the current flow, the voltmeter here will measure potential difference across the battery. So means this circuit, you must open the switch. Let's say we have a switch here. You open the switch, you have open circuit. Then the V here will become electromotive force. Okay, EMF. Mesti switch buka. Okay, kalau switch tutup, tak boleh. Okay. Okay, number 10, what is similarity between electromotive force and potential difference? Okay. A has the same voltmeter reading when switch is closed. No. Kita dah tunjuk tadi mesti open circuit, then only you have B equals to EMF. Have the same voltmeter reading when the switch is open? Yes, of course. Okay, has the same ammeter reading? No. Ini patutnya betul juga voltmeter reading D equals to E when switch open. Okay, tengok yang lagi. Has the same SI unit, so also correct. Sebab tak ada circuit given untuk reference. So tak apalah, kita boleh accept 2. Okay, number 11. Heating element resistance 20 ohm in a 240 volt electric kettle. Okay, so ini panggil heating element. What is power generated by kettle when connected to 240 volt power supply? Okay, just given ialah you ada voltage. Okay, so you have another one given which is resistance or apa ohm tadi? 20. Okay, formula apa yang relate? V dengan R. So kita ada V square over R. Okay, 240 volt divided by 20. Refer to the list of formula if you cannot remember all the formula for power. Okay, 2880 watt. Ini hanya formula saja, it's very direct. Okay, number 12, label issued by Energy Commission of Malaysia for 2 types of oven. So you can see the power use 311 kilowatt hour, 389 kilowatt hour. Okay, which comparison correct about 2 products? Okay, A, average annual energy consumption is same for B and Q, P and Q. You tengok dia punya unit pun tak sama. Kalau use for the same 1 year, same time taken, the power must be the same. If you want to mention that same product P has average annual energy consumption same, salah. Can see clearly tak sama 311 dengan 389. P tadi 311 kilowatt hour. Q 389 kilowatt hour. So energy consumption is different. Energy efficiency of P is higher than Q. Mana lebih efficient? Kalau same product but use more power, itu not good. Okay, so efficiency of product P is higher than Q. P is higher should be this correct. Okay, C, heat energy generated by Q is higher than P. Okay, maksudnya energy loss banyak. Okay, D, energy loss to environment by Q is lower. Dia hasilkan energy loss lebih banyak sebab tu dia consume same product consume more energy for same output. Jadi kalau output dia sama, efficiency untuk P lebih, maksudnya jawapan ialah B. Okay, paper 2. Diagram 3 shows a circuit consisting of 3 identical resistors K, L, M. 2 measuring instrument. Kita ada R and S. Okay. So the one that connect in series normally is ammeter. The one that connect in parallel is voltmeter. Ini saja yang kita ada untuk measure current dengan resistance. Current dengan voltage. So R ialah ammeter, S ialah voltmeter. Okay, bahagian B, when identical resistor is connected parallel to M, what happens to R and S? Tambah lagi satu parallel to M. If you increase the parallel one, identical, so effective resistance for parallel connection is smaller. So means if this one is smaller, the total effective of the circuit will become smaller, thus current increases. Okay. Current increases. Now current will be divided to three parts. Okay, 3 parts, same. Okay, I1, I2, I3. Okay. The voltage depends on the effective resistance across the 3 resistor in series. So means what happened to the voltage? Decrease. Okay, because effective resistance decrease, right? If you cannot understand this one, you can check. Let's say ini 6 volt. K ni ialah 1 ohm lah, let's say. Kita nak ada identical. Easy calculate, so I just put this one as 3 ohm. 3 ohm, 3 ohm, 3 ohm. Okay, if you cannot get, you can just put a value and try to calculate once again. R parallel equals to 1/3 plus 1/3 plus 1/3. This 3/3 equals to 1 ohm. So effective resistance for the whole circuit will be 3 plus 1, which is 4. Okay, so total current equals to total voltage divided by R effective. So you will have 6 divided by 4, you have 1.5 ampere. Okay, so you have current, you have voltage. So voltage across the parallel part equals to 1.5 times 1 is 1.5. Okay, And then 1.5 divided equally, you will get here is 0.5, 0.5, 0.5. Okay, so we have parallel part is 1.5 volt. Let's say we calculate without the third one here. So R effective will become 1/3 plus 1/3 is 2/3. So R effective ialah ini 1/, sorry, 1/. Ini ialah 3/2, which is 1.5 ohm. Okay, so R effective for the whole circuit will be 1.5 plus 3 ialah 4.5 ohm. Total current equals to 6 divided by 4.5. We have current is 1.33. Okay, so 1.33 passes through. Okay, this one. So the parallel part here for the first one is 1.33 times 6. Sorry. Effective tadi berapa? 1.5. 1.33 times 1.5. 2. Okay, so you can see from here, when you connect only two parallel resistance, current ialah 1.33 ampere, voltage ialah 2 volt. But if you add one more, jadi 3 parallel resistor, you have the total current is 1.5 ampere and total voltage ialah 1.5 volt only. So you can see current increase daripada, nampak tak? At first, 2 resistor ialah 1.33, 3 resistor 1.5. And then the voltage 2 resistor 2 ohm, 3 resistor 2 volt. So 3 resistor voltage ialah 1.5 volt. So you can see reading of current increase, voltage decrease. Okay. Tapi ini akan buang masa. Tapi you faham lah ya, kalau dia sambung secara parallel macam ni, effective resistance decrease, total effective resistance decrease, current mesti increase. Okay. Increase, decrease. Okay, number 2. Diagram 2 shows electric stove uses heating element made of wire. Electric stove label 2402 kilowatt. What is the meaning of 240 volt 2 kilowatt? This one we call it power rating. Okay, how to explain or define power rating? Okay. When the stove is connected to connected 240 volt of power supply or voltage also can, the stove will consume, akan menggunakan 2000 electrical energy 2 kilowatt maksudnya ialah 2000 joule per second. Okay, energy in 1 second. Okay, nampak cara penulisan kena mention 240 volt and then 2000 joule. 2000 joule of electrical energy in 1 second. Okay, itu ialah cara meaning of power rating atau label. B, calculate energy used in kilowatt hour for 30 days. Kalau you nampak ini, kilowatt ialah power, hour ialah time. So means if we want to calculate energy consumed, we are going to use the formula E equals PT. But P must be in kilowatt. T must be in second. You kena faham. Okay. So you want to calculate for 30 days. Okay, use 5 hours per day. One day, maksudnya 5 hours per day, 30 days berapa? Okay, itu yang kita nak jawab lah. Okay, E equals to power tadi ialah 2 kilowatt. So 2 time ialah 5 hours per day multiply 30 days. So kita akan dapat 2 times, so means 300 kilowatt hour ataupun unit. Ini unit for electrical energy, kilowatt hour. Okay, C, if cost is 20 cent per unit, calculate cost of using electric stove for 30 days. Okay, so means cost equals to number of unit used 300 multiply 0.2 ringgit. 20 cent. So we get ialah 60 ringgit. Maksudnya setahun dia guna 60 ringgit untuk cooking. Guna stove tadi. Okay, number 3, diagram 3 at 1.1 and 0.2 shows 3 identical. Ingat bila ada identical maksudnya same resistance. Okay, power rating 6 volt 12 watt. Voltage of battery 6 volt. Okay, so kita ada series connection. Bersebelahan macam ni, series. Kalau macam ni, connected to the same point across the battery. Ini parallel. So you must understand series punya properties dengan parallel punya properties. Okay, soalan A1. State the type of circuit in diagram 3.1 and 3.2. Series, parallel. Okay, bahagian B, resistance of each bulb 4 ohm. Dia identical tadi kan. Determine current flow in each circuit. Kena cari current untuk diagram 3.1 and 3.2. So means the parallel and the series one. Okay. 3.1 series. So ini semua ialah 4 ohm, 4 ohm, 4 ohm. Ini pun sama. 4 ohm, 4 ohm, 4 ohm. Okay, formula kena tahu. Series, ingat tadi diagram 3.1 ialah series connection. So So effective resistance R effective equals to 4 plus 4 plus 4. So you will get 12 ohm. Okay, you want to calculate for total current in the circuit, formula I equals to V divided by R. Means total voltage divided by effective resistance. Total voltage ialah berapa tadi? 6. 6 divided by 12. So you will get 0.5 ampere. Okay. Itu untuk series. Parallel, 1 over R parallel equals to 1 over R1 plus, saya terus ganti lah. 1 over 4 plus 1 over 4 plus 1 over 4 is 3 over 4. So R effective ialah for parallel pipe, ini ialah 4 over 3, which is 1.33 ohm. Okay, so what is current? I equals V over R. Total voltage 6, and then dia punya effective resistance 4 over 3 atau 1.33. Plus we get ialah 4.3 ampere. Can see the difference. Series current smaller, parallel current is larger. Okay, number 4, 2 electric circuit. So this one also we have 2 parallel and then, 2 series ini, series parallel. Okay. What is the meaning of potential difference? Remember the formula, V equals to E divided by Q. Electrical energy per unit charge. So we will define based on this formula, which is work done or electrical energy pun boleh to transfer or to move 1 coulomb of charge, okay, between 2 points in an electric circuit. Okay. Two points ni you can, maybe you measure from positive terminal to negative terminal, or you measure between about, okay, itu maksudnya 2 points. So okay, ammeter, okay, between 2 points, ataupun voltmeter the same. Tapi voltmeter tak adalah, voltmeter dia high resistance kan, kita tak nak bincang nanti kena buat. Okay, inilah. Okay, B. Observe diagram is switch A and B on while switch at C off. What will happen to bulb C? Kalau you off-kan dia, saya rasa ni soalan ni off ke apa? Dimatikan. Kalau dia off switch itu, maksudnya ialah it does not light up lah. Okay. Maybe we can change ini. Saya buat jawapan ikut pada soalan mana. Kalau C punya off, memang tak ada current lah, pergi C kan. Ni, non power C ni. Okay. So no current flow. Give one reason. No current flow to C. To bulb C. Ya. Okay, based on your answer 4.1, 4.2, compare EMF of the circuit. EMF ialah total voltage supplied by battery. So you can see from here using 2 battery. So it means same EMF. Okay, total effective resistance. In 4.1 is higher because series. Okay, connection of bulb. In 4.1 series and 4.2 is parallel. Okay, what is relationship between total effective resistance and connection of bulb? When the bulb is connected in series, the total effective resistance is higher. Okay, connect in series, total effective resistance is higher. Okay, ada soalan boleh tanya yang online dengan saya. Okay, number 5, diagram 5.1, 5.2 show a filament bulb and energy saver bulb These two bulbs give same amount of light intensity. Kecerahan yang sama lah, brightness yang sama. Okay, ni kita ada dua bulb. What is meant by power? Energy consumed in 1 second. Okay, joule per second. Okay, kita boleh tulis juga power is rate of work done company, rate of energy transferred. So in topic electricity, energy transferred will become or change to another type of energy, like become light energy, becomes sound energy, become heat energy. Okay. Calculate electrical energy supply in 3 hours in kilojoule. 3 hours in kilojoule. Okay, let's check the power. Okay, for the first bulb, 75 watt, second 20 watt. So, calculate electrical energy, apa formula? Sama ada E equals to PT. Okay, kalau you ada P, ada T, boleh. No mention, tak ada mention T, so kita akan guna formula lain. We have V, right? V ialah 240 volt. Okay, first diagram, power ialah 75. Second ialah 20. Oh, T ada 3 hours. T ialah 3 hours. So, E equals to PT. For first bulb, 75, you kena, 75 watt times 3. Kita nak dalam unit joule. 3 hours, you convert to second. Okay, kita ada 810 kilojoule. (5.2) 20 times 3 times 60 times 60. Ini dalam joule, kita convert to kilojoule. Okay, next question. Cost of electrical energy 30 cent per unit. Calculate cost of two types of lamp for 24 hours. So E equals to PT. Okay, this one kilowatt. So power kilowatt time hour. 75 divided by 1000 to change to kilowatt and times 3. Kilowatt hour. Okay, so cost equals to 0.225 times 0.30 ringgit. $0.0675 ringgit, ringgit. Oh, sorry, this one 24 hours. Yeah, sorry, yeah. It's not 3 hours. Dia 1.8, so 1.8 times 0.3 ringgit. So 0.54 or 54 cent. Okay, ini untuk first bulb. Second bulb. Okay, second bulb kita calculate di sini. Space dia saya besar sikit tadi. Equals to PT 20 over 1000 times 24. Kilowatt hour. Cost 0.48 times 0.3. Okay, so RM 0.144 ringgit. Okay. Okay, you can see for first one using 0.54, second one using 0.144. So which bulb is more economical? Give reason for your answer. Okay, you can see bulb. Okay, kita akan ambil yang first punya energy saver bulb. Sekarang pun ramai orang guna yang ni kan, energy saver bulb, because less energy consumption ataupun less energy consumed and lower cost. Okay, of course lah, jadi energy saver bulb. Okay, number 6, diagram 6.1 shows metal coated polystyrene ball, 2 metal plates. Kita nampak ini positif, negatif. Okay, the metal coated polystyrene ball is at, neutral at first, means same number of positive and negative charge. Okay, the metal plates connected to EHT power supply. A, when the metal coated polystyrene ball oscillate between the two plates for 3 minutes, 0.3 ampere of current flows. Calculate total charge transferred between the two plates. Q. Jangan risau dengan term-terms nampak macam complicated. Just look at what is given. You ada current, ada time, 3 minutes. So means 0.3 times 3 minutes convert to second. Okay, so you have the answer ialah 54 coulomb sebab charge. C huruf besar. Okay, bahagian B, frequency of oscillation of metal coated polystyrene can be increased by using one of the methods listed in table 6.1. Okay, earlier I already discussed that between two plates, okay, electrical energy or electrical or electric field, electric field strength E equals to V divided by D. Voltage of EHT divided by distance between two plates. Okay, so you want to increase the frequency, means you need to increase the strength of the electric field, means increase the voltage and decrease the separation distance between the two plates. Okay, jadi kita tengok sini method. Distance between two plates. Ini ialah D tadi. Kita nak dia lower. Mass of metal coated, kita nak dia oscillate, frequency increase. Maksudnya oscillate lebih laju. So mass must be lower. So EHT power supply must be high. Okay, let's try to check which one is suitable. Okay, dekat, long, medium, dekat. So I remove the long one. Saya ambil dulu medium dengan short. Okay, and then we have the coated polystyrene ball. Okay, let's say I choose low and medium. I remove the high one. Voltage of EHT supply must be high. Okay, so untuk 3 pilihan, you remove 1. Kalau 5 pilihan, you remove 2. Okay, kita dapat Z. Okay, based on the table 6.1, state suitable method to increase frequency. Okay, distance between the two plates must be short. So reason ialah increase the strength of electric field. Okay. Okay, mass of metal coated polystyrene must be low atau small pun boleh. Reason, ball swing faster. Jangan tulis the ball swing at high frequency. Frequency dah mention atas tadi. Okay, the ball swing faster ataupun at high speed. Okay, VAHT power supply must be high. Okay, reason. Boleh repeat reason. Kalau di sini you nak tulis increase electric field strength boleh, ataupun stronger electric field, atau stronger electric force pun boleh. Okay. C, based on your answer, choose the most suitable. Z tadi. Okay. Okay, one last part. I have more how many questions? Okay, for this one, I don't want to explain because I think there's some problems with this question. So I will go to the next one, the last part. Okay, calculation, 5 marks. Electric toaster has heating element of resistance 26.7 ohm. The current flowing while in use is 9 ampere. Okay, state suitable fuse for the toaster. To know which one is suitable, you must calculate the current. Okay, kalau 9 ampere, we must choose which is slightly higher than 9 ampere. Okay. So, you boleh suggest lah 10 ampere untuk fuse ni, higher than, a little bit higher. Okay, calculate voltage or supplied voltage. Okay, V equals to IR. $26.7. Okay, power dissipated, P equals to I square R. Okay. Formula ni you boleh biasakan lah ya. P equals to V square R. Okay, P equals to E divided by T. Okay. You ada P equals to I square R. Okay. P equals to VI. Okay. Ikut pada formula yang diberikan, ikut pada information yang diberikan. Okay, I think for today I will stop here because more than nearly 1.5 hours already. Okay. Okay, if you have question, you can write in chat rather before I end my class today. Ada soalan tak? Okay, if no question, then I will end class now. Okay, thank you for joining me. Bye.